Hello everyone, you are welcome back once again. I remain Victor Odigoma here. So, like I promised, we are looking at, you know, this is the the last problem we tackled in our last class some time ago. Okay, so if you were with us in that video, you realize that we were able to show how to, copy and complete the table of values for this relation here, and then plot the graph, and then use the graph to answer these sub questions. If this is the first time you are watching this video, I advise you to go back to that class, linear and quadratic graph class 3, and examine the procedure we followed in generating these figures, you know, constructing the graph, and then answering the sub questions. I promised us that when we are back today, I will be showing us how to use this graph to determine its gradient, the gradient of this curve at any point that the question might require. So assuming that the question requires us to say something like determine the gradient of this curve at x equals to 3. This is a U-shaped curve. It's not like the other one. Please, there's the other video I have just finished right now that shows how to determine the gradient of, a curve, and that one is N-shaped. So this one now is U-shaped. So I explained how to determine the gradient of the curve of an N-shaped parabola. I've done that. Please check out on that and also learn how the procedure goes. For this gradient, for the gradient of this U-shaped parabola, okay, we are looking at how we can be able to determine the gradient of it. Okay, if for instance that one is required to determine the gradient of this uh parabola at x equals to 3, okay, please use this information I am giving you to generalize, to understand whatever you are going to face out there, because the procedure will always be the same. Yes, if you understand what I'm going to show you here, definitely you will understand what you are going to do in another question out there. Okay, so if you look here, this is x being 3. Okay, this is x being 3. Let me bring it closer. You can see that x is 3 here. Okay, so this is the point, okay, where x is 3. Now what I will do is that I can draw a tangent to touch this curve at this point. Okay, because the gradient of a curve is the gradient of the tangent to that curve at that point. Okay, so the gradient of the tangent to this curve at this point is what I'm going to calculate. So what I will do is that I'm going to draw a tangent to this curve at this point where x is 3. So I can make a tangent. A tangent is a line that touches a curve at a particular point. So if I produce a line like this to touch this curve at this point, okay, and stop here, that is readable for me, and then can produce this and stop here also, that is also readable for me, and then can join it like this. Okay, so can you see clearly what I have made here? So now you already know that gradient by me g is equals to change in y all over change in x. Increase in y over the ratio of an increase in y to that of increase in x. So it mustn't be increased, can be decreased. That's to say the gradient can be positive or it can also be negative. So this thing is y2 minus equals to y2 minus y1 all over x2 minus x1. Now the little challenge per se. One my phase is how do I extract these informations from these informations. I hope you can see that clearly. Okay, how can I extract these informations from maybe an intended, situation, you know, here. So that's what I'm going to quickly show us how to do that. All right, when you come here, let me bring that again closer. Do you see that there is there is there is a change here on in the x-axis here? So I can call here my x1 and call here my x2. Look at it up there. So my x2 is 3 and my x1 is 2. Now in this direction, now this is the direction of y. You see the direction of y. So from here, this point of contact to here, there is a change in y. I don't know if you get that. So let me mark something here. This is a change in y, and this is a change in x. Do you get it? So if here is my x1 and here is my x2, here could be my y2, because you see, okay, come here my y2, okay, and here my y1. So you should understand that clearly. Here my y1, here my y2, because the change, the movement is okay in this direction. Okay, so there's a change in y over this interval, and there's also a change in x over this interval. So the reading here will give me my y2, that's minus 15, and from here I can determine my y1. Of course, I have to be careful to know what this graduation is saying. It was explained in the last class. Please take note. So every 2 block here is 1 unit. Since from here to here, which is 10 blocks, is 5. So that is to say that if here is minus 5, 2 block minus 6, another 2 block minus 7, another 2 block minus 8, another 2 block minus 9. So my y1 is minus 9. So my calculation will go like this: y2, which is minus 15, minus in bracket, this minus is in the expression, please take note, minus in bracket minus 9 all over x2, which is 3, and x1, which is 2. This will be 3 minus 2. So this will give me minus 15 plus 9 all over 1, and that is going to give me minus 15 plus 9 will give me minus 6. Yes. So G is equals to minus 6. Okay. I'm sure the explanation is very, very clear. Okay. This thing is minus. This is 9. Oh. I'm sure you saw what I wrote there. Okay. So I am pretty sure that the explanation I gave you here is good enough to help you to understand what I did here. Thank you so much. All right. Once again, if peradventure I decided that this triangle will not be in this position, is it possible for me to have it like this, okay, and like this, okay, connect it like this so that the tangent will run like this? Let's see what happens there. So if I make another tangent to also touch the curve at x being 3, let's see what it will give us. Whether if you are doing it in that situation, in that way, whether you are safe. Okay, you see the tangent at x equals to 3. Okay, this line that touches this curve at that point. So we can connect here to be our change in y, and here to be our change in x. So our change in y, here our change in x. So this will be my x2, this will be my x1, and this place from 0 to minus 9 will be my change in y. Okay, let me quickly take the calculation there and see what it gives us. G equals to y2 minus y1 all over x2 minus x1, so my y2 being minus 9 minus 0. I'm sure you can see it with me. Let me show you. Okay, this is my y2 being minus, you can see it is 2 steps to 10 minus 10. So from here you can see that this is minus 9. Okay, read from minus 5, 2 block 1, 2 block 1. You can see that here this is minus 9. Look at it there. This is 0. Okay, so the change here is minus 9. Consider also the change over here in x. Somewhere here, this is 4. The middle here is 4.5. And this is 3. So my x2 is 4.5 and my x1 is 3. So all over 4.5 minus 3. So it will give us minus 9 over 4.5 minus 3 will give us 1.5. So let me see by my calculation what 9, I know it's negative, but let me just say 9 divided by 1.5 equals to 6. So this calculator gave me 6. I know this minus is here, so it will affect it to become minus 6. So you realize that both ways gave us the same result. Remember how I position? Look at it again. I drew a tangent to touch this curve at this point, x being 3, and then I produce it like this. Okay, this is my change in y and this is my change in x. Or I drew a tangent to run like this and touch this curve at this point, x being this, and this is my change in y and this is my change in x. And I did the calculation and both ways was able to give me same result. So there's not too much story again to, I am trusting God that this explanation I gave you is good enough and can help you to face any challenge that has to do with gradient of a quadratic curve or in a quadratic graph. Okay, thank you so much for watching this video. Remember to also check out the other one where I did the gradient of an N shape. This is U-shaped parabola. The other one is N-shaped parabola. Also check out how I explained the gradient of that one too. It will also help you to be much more balanced to face your questions in examination hall. Thank you very much for watching this video. I remain Victor Odigoma Ohia. I'm also still going to take you through the equation of the line of symmetry to this. I'm coming back to that in the next video. The equation of the line of symmetry to this parabola. I'm going to do that in the next video. Thank you so much. So stay put. Please subscribe to this channel so that you stay put, you get acquainted with whatever we are discussing here. Share it to your friends and help them to be part of this learning and to be a blessing to them too. Subscribe and click on the notification button so that you can be notified of our developments. God bless you.